today there will be a lecture on all form definitions. 목걸이가 없는데. And we will cover second part of all form definition. And Mino is not available. We will lead the discussion session. And homework 3 will be out probably this evening. Any question on schedule? No. Going on the performs. And the book. And the chapter on performs. That is divided into two. So next week on Monday we will have another class on lines. That is a part of performance. Right. So today we will maybe covering the 5.1 and 5.2 perform definitions, and lines and hydrostatic will be covered next. This is I took from museum, National Museum of Korea. This is coming from 1592, long time ago. How many years? 420, 40 years ago. There was a war between Japan and Korea. And the turtle ship looks like a turtle. Was famous at the time, and probably this looks like a main leader's ship, commander ship of Korea, because this is picture coming from Korea, and I guess the top side can be the Japan ships. I'm not sure that there is another picture. It is coming from Japan side, right? You may not notice that, but we share the Korean, Japanese characters, but there are some Japanese character too. Chinese character and Japanese character together. So this looks like a commander ship of the Japan and then small ships. So two groups of. Oh, you see that flag is big flag of Japan, and fight each other at the Korean Ocean, near the Korean Ocean. So this is a hull form, the outer shape of the ship at the time, 400, 500 years ago. At the time there was no engine, no car, no train, right? Only ships. They use only wind and rowing, right? But the Korean ship side, this is Korean side, Korea turtle ship, and this is Japan ship. You see it from the picture. The form is very wide and short ship. Turtle looks like this one, right? Turtle is a rounded shape, right? Wide and flat. And Japan ship is narrow and long, skinny ships, comparing to each other. And then the property is that because it is wide, this is stable. Stable means that it's not easy to capsize. Right? Wide ship, it's not easy to capsize. And then also have a wider deck area. Fat ship. But this one is very narrow, so that slender. It is easy to propel toward the wave and water. Cost-wise, this is easy to build. It is flat and round. But there is no engine. But I'm saying the power. You can say power. It should be modified. Small power is required, or faster, or small power. So that it is coming together, slow speed, and this is high speed. And if goes up to rough sea, it is not good. Right? Sea sickness means ship is moving more, coming when the wave is coming. And this one is good for because it's sharp, so that can piercing the wave. Right? So looks this ship is better, right? High speed and good seaworthiness. But the battle was different. The result. Why? There is another story there. But anyway, because this ship is intended to use near the coastal line. That's why they don't need to have a slender body. This one, they need to come to Korea. And the distance is not far away from between Japan and Korea, but the sea was rough between them. And also, Japan is an island country, so that they their sea water is very rough compared to the Korean sea water. That's why they need to have a good ship in rough wave, right? And high speed. So that's why the differences are coming. The background. Can you remember this kind of one from the hydrodynamics class? Right? Drag coefficient. So blunt shape, something like a square is highest, right? Or right, short cylinder. Short cylinder means this way, higher. Then the circle or minimum is streamlined body, right? Very big difference, right? 25 or 30 times difference, drag coefficient. That's why we are doing slender body shape, right? Rather than blunt body shape for the ships. And narrow and sharp edge at the front to reduce their coefficient. So another one, same one, but with a different viewpoint, drag coefficient, and also the equation, and the frontal area is important. The blunt one is very high, right? And this one is good, powerful. So you remember the hydrodynamics you already learned from another class, right? This is looks like a miniature battleground, and in a model pool of water, right? With waves are also generated. So this is looks like a turtle ship. I guess this is a Japanese warrior or something. No? Right. And this is another comparison, but I copied from another person's one, so that Korean characters are still there. But I retranslated, right? Turtle shape, but this one is before the coverage of the top face. So we call this a panokson. So you may expect that this turtle ship, the baseline is ordinary vessel, but they make another technology to cover it. That try to protect from the Japan warriors coming into the ship. So we call this is a protection and cladded and steel plate cladded. But the big difference coming from they use guns, big guns. Rather than Japan warriors use short range rifles rather than cannon. So that you can expect that they want to be fight far away, right? Long range gun is coming. And Japan want to come to the close to the ship and fight nearby, right? Using rifle and knife. So tactically, they have a differences. And speed is high, right? Speed is high. Slow. But they need a wide deck area and stable deck area because of their guns, big cannons. Otherwise, ship is capsizing because of the cannon create a force back. So that's why I'm trying to explain what the difference is coming from hull shape. Hull shape is different in the war time. This is a typical design requirement. Owner means a ship owner that ordered a ship to construct in a shipyard. Similarly to myself, I ordered my home, two floors home, to construct to the constructor, local constructor. So I was a homeowner, and I have a requirement set to the constructor. We have a contract to build my home, very similar to building a ship. So key requirement can be a ship type, it can be a yacht, it can be a racing boat, it can be a cargo ship, it can be a submarine, and then usually the cargo weight is important for the cargo ship, or capacity means say cruise ship, how many passengers, that is important, right? Because that is the money coming, how many passengers we can accommodate, or how many containers, TU, or how many soldiers, or how many missile or torpedo, right? That can be the capacity in general. And speed. And limitations, something like the ship should enter to the Sydney port. That Sydney port has a bridge, so that they should under the bridge, so the height should be minimum in this way. And biggest limitation coming from the canal. What is the name of the Panama Canal? And Egypt Canal. What is the name of the Egypt Canal? Suez Canal. That kind of thing. So the limitation coming from the breadth of passage, and also the depth of the water passage. This is a man-made channel. So these are limitation. Also limitation coming from the pollution. Right? Pollution. We studied that on Monday, right? About pollution limitation. MARPOL or safety requirements, pollution requirements, and also special. So pollution requirement. Another one, CO2 efficiency. But this is just a rough comparison because this is a big ship, biggest ship, so that per ton, this is, you need to know that ton kilometer divided by gram CO2 generation. So that small one is not good, right? So truck is smallest, and rail, and smaller ships, and then big ships. So that, but you can see that the size difference is 100 times. Green ship concept. NYK is Nippon Yosen, I think so. It's a Japanese shipping company, and they provide a new concept ship. Looks like this one, and they use wind energy, and also solar energy, solar plate. And you can see that this is submerged part, so that they have a less, how can I say, the wave forces to the hull. And then 8,000 TU fuel cell, right? And then solar and wind. So that CO2 emission is very good. They use this. It is not constructed yet. This is just concept ship. And whole form definitions. So linear measurement is the length and breadth and depth. You already see this. And also 2 and 3-dimensional coefficient. We call this is a Hall-form coefficient. We'll see later more. And speed. Also, relative means not absolute speed. It's a relationship between divided by something. Proportion is coefficient. Ooh, it's a Korean character, but I just want to show that there are not one single length. This is our 3 different length measures. Important for you need to memorize this. Length overall is all together. The maximum, tip to tip, tip to tip, LOA, and length waterline is this is waterline, right? But waterline is changing as cargo loading is changing, right? Every time. But we know that maximum draft, or we call this is a design draft. Design draft is the maximum draft limitation. So we call this is a design load line or waterline length. LWL. And LBP is more important for shipbuilders company, shipbuilding company, because between AP and FP. But this is a short name of after peak, and this is a fore peak. Why? Because they construct the ship based on this length. And they usually divide this length into about 20 stations. And then also more on, say, 150 or 200 divisions. Right. So each one, you may see this small ticks, right? This is some meaningful measures. So they equally divide that ship into several numbers because they want to do some transverse frame. Transverse frame is similar to this one. Rib. How many big rib and small rib is constructed per ship is decided by designers for the structural reasons, strengths. So that's why they use this one is important. Also, each part or compartment or hold is divided by based on this frames. How many ribs, right? Very similar to building. Building we have pillars, important structurally important to construct. Pillar is the most important, and also walls. But you may notice that walls are different. Some walls are very important for structural reason, and some walls are just for decoration or dividing. So when you modify the structural parts to make a bigger room or smaller room, right? You may use dividers, or you may delete dividers. But the structural walls cannot be modified. If you want to modify the structural parts or you need to get permission again, calculation again, and permission. So that they use this kind of divisions, important for the construction and structure. That's why they use classification, society, and insurance, and tax are coming based on this length. But this one is important for hydrodynamics, motion, resistance, propeller, something like that. Hydrodynamics, water is related, motion is related. But this one is for construction and structure. Question? Structure. Transverse hull form, right? Transverse midsection. And this looks like a bulk cargo ship midsection. Bulk carrier, grain carrier, coal carrier, or ore carrier. Why? Because of this shape. I noticed, you may not notice. This is good for grains, right? They pouring grain to the entrance, right? The shape is looks like this way, right? This way, looks like this way. So without this shape, usually they have an empty space. And then if you have an empty space, ship is rolling, then cargo is shifting. So that's why they use another. This can be used for another reason. Yes, draft is already explained to you. The need to embed this baseline, and there's two draft lines, right? Design draft and scheduling draft. Very similar, very small difference. Sometimes it's the same, but this is based on structural design, and this is for cargo capacity and hydrostatic calculation. So dead weight calculation, speed and power. This is structural design. And this is a molded something, and extreme, where is it? Molded something. Where is it? No, not in space. See, the molded means this plate, this steel plate is about thickness. Thickness, did I told you about thickness of the ship plate, steel plate? Yes. How much?
2 centimeters.
2 centimeters. Good. Right. Right. How about automotive?
It's 2 millimeters.
2 millimeters. Less than 1 millimeter. The outer skin. There are more thicker pieces inside the car, but I mean the outer skin. Right. So the molded means excluding shell plate thickness. The 2 millimeter is excluded. So inside the line or outside the line. Right? Very small change. But in terms of whole volume, it's several tens of tons. That gives you big difference for the money and cargo, displacement, and also other things. Cargo capacity. Right? 1,000 kilogram. 1-ton truck. This is 1-ton truck. It is very famous truck in Korea. 4-ton. Right? Very same as cargo ship. Right? They need to have a maximum cargo capacity. There is a dead weight of payload. So it is maximum cargo 1 ton can be loaded in this truck. And her form structure shape very complex. So this is a double bottom tank top plate. And double bottom is very complicated because of, and this is a frame. Right? I explained this one. Each frame, right? And sometimes there is a bigger frame. So maybe here and here, maybe 3 times, 4 times larger frame is coming. So main frame and smaller frame between. That is each time LBP is divided by this frame spacing. So we call this frame spacing. It's based on LBP divided by 200 or 120 depending on the ship, right? Or structure design. Right, molded is coming, right? Molded means there is including or excluding? Molded. Can be there is no example. Right. And waterline, freeboard. This one is very strange ship, but this is an empty ship, I guess. Right? So this is not design waterline, empty water. Dead rice, something more different. Small terminology, and this one is wood ship. The turtle ship is made of wood long time ago. So now there is no such a wood ship anymore. Nobody uses wood ship. Very special, all the traditional persons are using this one. But this is not for normal or day life ship. Is FRP, aluminum, steel. No. But still, there are person who is making a wood ship. And old ways. Weight. You already know this, right? Lightweight. Total hull steel weight. And equipment also. Right? So it's a weight when the shipyard finish the ship construction. Right? Lightweight. No cargo. No passengers. Only there. So same as when you have your new car just delivered to you, right? This is an empty car, is a light car, lightweight of the car. Same as this. And dead weight includes cargo and then some more, some oil, fresh water, and crude, and crew members, and luggage, and or lubrication oil in the engine. So displacement, I already explained that. So lightweight shield, deadweight plus, and then this one is this one, right? And this is a distribution along the LVP, right? BP is here, so there are a little more. So ROA can be ROA, right? ROA, and weight distribution along the length line, right? This is weight. You need to calculate this one. You need to draw this one as a ship designer. So area of this curve can be total weight of the ship. Right? And then displacement is coming from buoyancy, and buoyancy coming from the pressure coming from the water. Right? That should be balanced together. Right? Weight, including all cargo and others, right? Whole cargo, and then so this one can be many different, not many, several different curves. Lightweight curve, cargo curve, and altogether curve. And also loading condition. Loading condition means some cargoes, some of the containers loaded, unloaded, right? At the Singapore port, at the Busan port, at Los Angeles port, loading and unloading. So changing, right? And fuel is used, fuel is loaded, refueling, rewatering. Every day is changing, right? So curve weight is changing every day. But you need to calculate typical curves for your design. Bulwark means shape at this portion, we call it. But this one is angled and straight up, right? Angled and straight. Vertical type. But the slanted one means this type. This is a rounded shape, straight, and this way. So two different types, and O, bulbous O. Question? No question.
This is a strange question. I have seen that picture a couple of times.
This one?
No, the previous picture. Yeah. And I always wonder, why does the front look like that? Why do they make it like that? Is there any?
This is bulbous valve. Bulbous valve. This is another good topic for explanation. But simple answer is that wave, cosine wave, and sine wave, and together equal no wave. Simple idea. So this one can generate another wave. When there is no bulb, the ship generates wave, right? But by adding this one, we can somehow canceling each other. There is an idea of bulbous. But sometimes it works, sometimes it does not work. because phase difference between wave is not easy to match each other, right? Right? And size also, length, size, phase, all should be same, right? To cancel each other. But anyway, the baseline idea is this one. Long time ago, Roman ship, they do this one, but this one is for attacking, puncturing the wooden ship at the side. That is not for the wave bridge, but modern ships is for this side. Any other questions? Come.
Okay, good afternoon, everyone. Today, most of the materials for this lecture was derived from this book, by the way, so it's just a reference. I'm just going to continue talking about what the professor talked about. I'm going to talk about halls a little bit. So what is a hall? A hall is basically the watertight body of ship. There are all different kinds of halls, and there was a very short video that I found that I thought it explained it pretty well. So let's see if we can watch it here.
Types of hulls. Flat bottom boat. They are generally less expensive to build and have a shallow draft. They can get on plane easily, but unless the water surface is perfectly calm, the ride can be rough because the flat bottom hits each wave. They are less stable and require careful balancing of the cargo and crew. V-bottom boat. The V-bottom rough waters, but needs more power to achieve the same speed. Many runabouts use the V-bottom design. Round bottom boat. It moves easily through the water, especially at slow speeds, but tends to roll unless fitted with a deep keel or stabilizers. Many trawlers, canoes, and sailboats have round bottoms. Multi-hull boat. Catamarans, trimarans, pontoon boats, and some houseboats have a multi-hull design. The wide stance gives greater stability. Each of the hulls may have any of the bottom designs described above.
Yeah, those are different kinds of halls. So in the next few lectures, we're gonna talk about different kinds of coefficients, and in those coefficients, we're gonna have a lot to talk about displacement. I'm sure you guys know about it. I'll just remind you. Displacement is basically when you put an object inside a fluid and then you immerse it. The amount of the volume of the water or any kind of fluid that pops out as you immerse the object in that fluid is basically called the displacement. And we're going to use this in the next few lectures. So the very first coefficient that we have is the coefficient of fineness of water plane area, which is basically the water plane area divided by the area of the rectangle that has basically the same length and same breadth. I'll get back to this, and you can actually see the picture here. I'll get back to this because it can get a little bit confusing when I introduce another coefficient later. So I'm going to talk about also the block coefficient. Block coefficient basically represents the bulkiness, the fullness of the hull, and it's the ratio of the volume of the displacement that we just talked about to the volume of the rectangular of the block. So in the previous slide, if you remember, I talked about almost the same thing. But it was the area. So the difference between this and the previous one is that in this one we talk about the volume, but in the previous coefficient we're talking about the area. And those ships that they have high block coefficient, it means they will have lower speed, but they can have basically higher cargo, and vice versa if they have lower coefficient of blockness. So basically, the coefficient of blockness concerns with the volume, but coefficient of fineness of water plane area is concerned with the area. And this is basically the shape of it, as you can see. So you get the you get the rectangular, and then it has the same length, same width, and same height as the ship. Another coefficient that we have is called the midship section coefficient, which the midship coefficient basically is also similar to the previous coefficient, except that here we take the area of the ship that is actually submerged in the water. So in the in the first slide here, we take the whole area. In the block coefficient, we take the volume, and in the midship section coefficient, we basically take the area of the ship that is actually submerged in the water. So that's the differences between this. Did you guys understand all of it? The midship coefficient and the block coefficient and the water plane area. I'll summarize all of them at the end. I mean, not I. Somebody has summarized it at the end in the video. Yeah. Just to wrap it up, because we might need it for the future slides. So for the midship, it's the area that is submerged. For the bulk, it's the volume, and for the water plane area, it's the area of the ship. So there's another coefficient. Don't ask me why they have so many. I don't know. But then there's another coefficient. It's Prismatic coefficient. It's again similar to all the previous coefficients, except that here, instead of rectangular, you are using a prismatic area, and here it's not volume. The only coefficient that is concerned with the volume is the block coefficient. The rest of them basically are concerned with the area. And this one, instead of being concerned with the area of the rectangular, is concerned with the area of the prism. So you can basically see the volume, see the formula there. And so the Freud number is basically the ratio of the flow of inertia to external field. As you can see, it's you can get it by the formula here. There's a very good video on YouTube with a guy who's actually showing the Freud number in his kitchen sink. I wanted to put it up, but the sort of the voice is terrible, so I just didn't put it. So if you're interested, later on you can just look up for Freud number in kitchen sink, and it's a pretty fun video. So I talked about the displacement, and then there's another ratio. It's called displacement to length ratio, and this one you can think about it as basically fatness versus slimness, and it predicts speed and power. You can even draw an analogy, let's say, to humans. You know, humans, we also, if you take the displacement as a whole volume and then length and the height of a person, you can also get the same concept of fatness and slimness. And in ships, it tries to basically predict speed and power. It's a non-dimensional expression, basically, of how heavy or how light a boat is. And it's calculated by dividing the boat's displacement by 1/100th of the waterline's length cubed. I wanted to just put simply what hydrostatic curves are, or what they actually, what sort of information you can extract from them. Hydrostatic curves, basically, they give you information about the buoyancy, about displacement, and center of flotation. And one of those hydrostatic curves is the Boyden curves, as you can actually see down here. And there are two more terminologies that we're going to cover. One is the LCB and the other one is LCF. LCB is basically the longitudinal center of buoyancy. It's the center of the immersed volume. And if you remember from the previous slides, in the immersed, we use the midship plane. And then we have the LCF, which is defined as a longitudinal center. So LCF is basically the center of the water plane. And what basically connects these LCB to LCF is through the trimming moment. Trimming moment, for those of you who have studied anything related to mechanical engineering, is basically the torque. So it's the torque that you calculate around the LCF. And so there is a long video that I have picked a very short part of it that basically summarizes what I just explained. It's like a 2-3 minute summary of everything that I just
explained. Block coefficient is a very important one in terms of for how you can compare different ships. Even if they're the same kind of ship, you can compare them using the block coefficient. So it describes the overall fullness of the hull. And you can see here, so it's the total volume that it could possibly take up based on length times beam times draft. But then you compare that to how much it actually takes up, right? Which is the volume in red here. So just like you calculate CB here. Again, the length is usually the length on the water line. For a destroyer that is primarily concerned with speed and performance, it's going to have a finer hull, so it will have a lower block coefficient. But for a very large tanker, which is trying to haul a bunch of cargo, it's going to have a much fuller hull, which means its block coefficient will be higher. So again, this is one number that can compare hulls that are very complicated and may look very differently. You can boil it down to a number that you can sort of wrap your head around. So first lecture in our series.
That was the block coefficient that I wanted everybody to understand. So there are 3 takeaways that I want you guys to. One is the block coefficient, one is the mid shift, and the other one is the area. Did you guys understand all of it, or anyone has any questions? All right. Thank you.
We have enough time for discussion.